welcome to Mathematical Podcast, where we break down mathematical concepts in a fun and relatable way. I'm your host, Vanessa, and today we're going to tackle a topic that most of us encounter at some point, which is illustrating linear equations into variables. I have with me today my three brilliant minds, Miss Ruby Jane, Myla Jane, and Justin. Let's make math exciting, folks.
Hey everyone, can't wait to dive into today's topic.
Hi, it's going to be fun. Linear equations may sound scary, but once we get into it, you'll see how manageable they are.
Yep, totally agree. We're going to make this an engaging session where everyone gets to learn step by step.
Okay, so let's start with the basics. What exactly is a linear equation into variables? Ruby, why don't you start us off?
Sure, Vanessa. Okay, so a linear equation into a variable is essentially an equation that can be written in the form ax plus by equals c, where x and y are variables and a and b and c are constants. The key thing to remember here is that this equation will always graph as a straight line in a coordinate plane.
That's a good point. Myla, can you break it down a bit more? What makes it linear?
Okay, absolutely. So it is called linear equation because when you plot the equation, the graph forms a straight line. So you remember there's no curving or zigzagging, just a straight path. So that's because the exponents of x and y are both 1. If they were anything higher, we'd be dealing with curves or other shapes.
Okay, so it's all about keeping things straight. Literally? Justin, why don't you give us an example of a simple linear equation?
Gladly, Vanessa. Well, let's take the equation 2x plus y equals 6. That's a linear equation with two variables which are x and y. The constants here are 2 and 6. So we can manipulate this equation to understand that values of x and y will make the equation true.
Alright, so now that we know what a linear equation looks like, let's talk about how we can represent it graphically. Ruby, can you walk us through the process?
Okay, sure, Vanessa. So to graph a linear equation like 2x plus y equals 6, the first step is to solve for y in terms of x. So let's rearrange the equation. Y equals negative 2x plus 6. Now this is in the slope-intercept form y equals mx plus b, where m is the slope and b is the y-intercept.
Okay, so that means the slope or how the steep line is negative 2. So and the y-intercept, which is where the line crosses the y-axis, is 6.
Okay, so once we have the equation in this form, how do we actually plot it, Justin?
Well, we start by plotting the y-intercept. So we could go up to the point 0 and 6 on the y-axis. Then, because the slope is negative 2, we move down 2 units and over 1 unit to the right to plot another point. Connect those dots and you have your line.
Nice! Simple enough, right? Let's try another example. How about x minus y is equals to 3? Ruby, what do we do here?
Alright, great example, Vanessa. Now first, we'll rewrite the equation as y equals x minus 3. Now Myla, can you explain what the slope and intercept are for this one?
Of course. So here, the slope is 1 and the y-intercept is negative 3. So that means we start at 0 and negative 3. And for every unit we move to the right, we go up 1 unit. So from 0 and 3, negative 3 rather, the next point would be 1 and negative 2.
Exactly. And as we keep plotting points, we connect them to form the line. Now, if we had to check whether a point like 3 and 0 is on this line, we would substitute x equals 3 and y equals 0 into the original equation. So does it hold?
Let's see. So 3 minus 0 is equals to 3.
Awesome! So that's a big takeaway for our listeners. Once you understand the slope and intercept, you can quickly draw the line and even check if certain points belong to that line.
Yes.
Now, some of you might be wondering, where am I going to use this in real life? Let's tackle that. Justin, can you give an example of how linear equations might pop up in real life scenarios?
Absolutely. So one common example is budgeting. Let's say you have $10,000 to spend in two types of expenses, just like rent and utilities. So if your rent is $700 per month and your utility costs vary, you can use a linear equation to figure out how much of your budget is left for utilities after paying your rent.
Or you can think about distance and speed. So if you're driving at a constant speed, you can use a linear equation to figure out how far you've gone after a certain amount of time. So like distance is equal to speed times time. So that's a linear relationship.
Okay, folks, it's time for our quick fire round. I'm going to throw out some linear equations, and I want you all to tell me the slope and y-intercept as quickly as possible. Ready? Here we go! First equation, y is equals to 3x plus 1. What's the slope and intercept?
Slope is 3, intercept is 1.
Alright, so next one, y is equals to negative 2x plus 4.
Well, the slope is negative 2 and the intercept is 4.
Great job! Then the last one, y equals 5x minus 7.
Slope is 5, intercept is negative 7.
Wow, you guys nailed it! Listeners, how did you do? Comment your answers and thoughts on today's episode. This has been an awesome session, everyone. We've covered the basics of linear equations in two variables, discussed how to graph them, and even looked at some real-world applications. Ruby, Myla, Justin, thank you so much for sharing your insights.
It was a blast. Linear equations don't have to be scary. They're actually quite useful.
Definitely. So I hope our listeners feel more confident tackling them now.
Same here. Remember, it's all about practice. The more you do it, the easier it gets.
That's a wrap on our first segment. Stay tuned and we will be back for our next topic, which is finding the slope of a line given 2 points.
Imagine a time in the Philippines when math was not yet invented. People relied on instinct and trial and error to build their homes, gather food, and solve everyday problems. There were no numbers, no calculations, just guesswork and hope. But look at us now. Math has become a powerful tool that makes life easier, more exciting, and, believe it or not, fun. Math isn't just about boring equations or tricky formulas. It's about solving puzzles, exploring patterns, and unlocking the mysteries of the world around us. From counting your allowance to designing video games, math is everywhere. Thanks to math, we can send rockets into space, build bridges, and create amazing technology. Math is behind all of this and more. And the best part? Math helps you build confidence. Every time you solve a problem, you're growing your brain, sharpening your skills, and preparing for an exciting future. So whether you're playing with numbers, exploring shapes, or cracking puzzles, math is more than just fun. It's the key to understanding the world around us. Everyone can enjoy math. Join us and let's make math fun together.
Hello everyone and welcome back to another segment of Mathematical Podcast. where we turn complex math concepts into fun and engaging discussions. Again, I'm your host, Vanessa, and today we'll continue our journey into the world of linear equations. But this time, we're diving into how to find the slope of a line given 2 points. Joining me again are my amazing co-hosts, Miss Ruby, Myla, and Justin.
Okay, hey there! I'm ready for another math adventure. Are you?
So hi, let's make finding the slope as easy as pie.
Yeah, we're back to show you how slopes can be your new best friend in math.
Alright, let's start by answering a simple question. What is the slope of a line? Ruby, can you break it down for us?
Okay, sure. So the slope of a line basically tells us how steep the line is. More formally, it's the ratio of the vertical change or rise to the horizontal change or run. So between any 2 points on the line. So the formula is m equals to y sub 2 minus y sub 1 over x sub 2 minus x sub 1, where m is the slope and x sub 1 and y sub 1,
X sub 1, Y sub 1.
where m is the slope and x sub 1, y sub 1 and x sub 2, y sub 2 are 2 distinct points on the line.
Alright, so essentially, the slope is all about how much y changes compared to x. Myla, can you explain what this might look like in a practical situation?
Sure. So, imagine you're walking up a hill. So the slope is like asking, how steep is this hill? So if the rise or the height of the hill changes a lot compared to how far you walk forward, the slope is steep. So if the rise is small compared to how far you walk, the slope is gentle. In math terms, the bigger vertical change compared to horizontal means a steeper slope.
And that's true, whether the line is going up or going down. A positive slope means the line is rising as you move right, and a negative slope means it's falling. And it depends on the change in y over the change in x.
Okay, now that we know what the slope represents, let's get into how we can calculate it. Ruby, can you walk us through the steps using the formula you just mentioned?
Okay, of course. Now let's take 2 points, say 1 and 2 and 3 and 6. So to find the slope between these 2 points, we'll use the formula m is equals to y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. So here, x sub 1 is equals to 1 and y sub 1 is equals to 2. And x sub 2 is equals to 3 and y sub 2 is equals to 6. First, we calculate the change in y. Y sub 2 minus y sub 1 equals 6. 6 minus 2 equals 4. Next, we calculate the change in x, in which x sub 2 minus x sub 1 is equals to 3 minus 1 equals to 2. Okay, now we plug this in formula. Now we plug this into the formula. M equals to 4 divide 2 equals
2.
Okay.
Alright, so the slope is
2.
That means for every 1 unit, we move to the right along the x-axis. We move 2 units up along the y-axis. So Myla, what does this slope tell us about the line?
So that's a great question, Vanessa. So this slope tells us the line is rising pretty steadily. So 2 units up for every 1 unit to the right. So the line is climbing at a consistent rate, and since the slope is positive, we know it's sloping upwards from left to right.
And don't forget, this formula works for any 2 points on the line. And as long as you know 2 points, you can always find the slope.
Okay, so let's talk about the different types of slopes we encounter. We've mentioned that a positive slope means the line is going up as we move right. What about negative slopes, Ruby?
Good one. A negative slope means the line is sloping downwards. For example, we have the points 3, 4, and 6, 2. We can use the formula again. Y sub 2 minus y sub 1 equals 2 minus 4 equals negative 2. Now x sub 2 minus x sub 1 equals 6 minus 3 equals 3. So the slope is negative 2 over 3. Okay, so this negative slope tells us that for every 3 units we move right, we move 2 units down.
Nice! And what about when the slope is 0? Myla?
Zero slope means the line is perfectly horizontal. So there's no rise, just a run. So for example, if the points are 2, 3, and 5, 3, the y values are the same. So y sub 2 minus y sub 1 is equals 0. So that makes the slope 0, which tells us that the line is flat.
Now, what happens when the line is vertical, Justin?
Great question. Well, a vertical line has an undefined slope because in that case, the x-coordinates of the 2 points are the same. For example, for the points 4 and 2 and 4 and 6, well, x sub 2 minus x sub 1 is equals to 4 minus 4 and it's equals to 0. So which makes the denominator of the slope formula 0. You can't divide the 0, You can't divide by 0, so we say the slope is undefined.
So exactly. Now, let's tackle a few more example problems so our listeners can really get the hang of this. Ruby, can you throw us another example?
Okay, now let's take the points 2 and 5 and 6 and 9. Using our formula, y sub 2 minus y sub 1 equals 9 minus 5, it equals to 4. Now, x sub 2 minus x sub 1 equals to 6 minus 2, it equals to 4. So the slope is 4 over 4 and it is equals to 1. This tells us the line rises at a steady rate, 1 unit up for every 1 unit to the right.
Okay, my turn. So let's try something with a negative slope. If you have the points 0, 4, and 2, negative 2, so we have y sub 2 minus y sub 1 equals negative 2 minus 4 equals to negative 6. And then we have x sub 2 minus x sub 1 equals 2 minus 0 equals to 2. So the slope is negative 6 over 2 equals to
Negative 3.
So the line is sloping downward 3 units down for every 1 unit to the right.
Very good. So now let's talk about where we see slopes in real life. Justin, do you have an example?
Well, definitely. One of the most common places you'll see slope in action is on roads. Have you ever seen a road sign that says something like 10% grade? That's a slope. A 10% grade means that for every 100 units, you move horizontally. The road rises or falls by 10 units.
And slopes are also important in construction and architecture. So engineers need to know the slope of a roof or a ramp to ensure it's safe and functional.
So even in businesses, slope can represent rates of change. For example, if you're tracking sales over time, the slope of the line on a graph can show how quickly sales are increasing or decreasing.
Alright. Listeners, it's time to do a little interactive example with all of you. Grab a piece of paper or your phone to follow along. I'm going to give you 2 points and we'll all calculate the slope together. Ready? The points are 3, 7 and 7, 15. First, find the rise or the change in y. Myla, can you walk us through it?
Of course. So we have y sub 2 minus y sub 1 is 15 minus 7. So which gives us 8. So that's our rise.
Great! Now, Justin, what's the run or the change in x?
Well, the run is x sub 2 minus x sub 1. So it will become 7 minus 3 is equals to 4. That's the run.
Oh, now, Ruby, can you finish it off and calculate the slope?
Okay, so the slope is m equals 8 over 4 is equals to 2. So for every 1 unit you move to the right, you move 2 units up.
Awesome, everyone! And how did our listeners do? Did you find the problem easy? So, comment your answers below and let us know how you followed along. Okay, it's time for a quick fire round again. I'm going to give you all pairs of points and I want you to find the slope as fast as possible. Ready?
You ready?
Here we go! First set. 1, 3, and 4, 7.
Slope is 4 over 3.
Very good. Next, 2, 6, and 5, negative 3.
Slope is negative 9 over 3 or negative 3.
Nice one. The last one, 3, 9, and 3, 2.
Its slope is undefined. Well, it's a vertical line.
Alright, very good everyone. You all nailed it. And how about you, listeners? Hope you're keeping up. Send us your answer or comment your answers below or ask us any questions you might have in the comment section. Thank you everyone for your participation. That's the wrap for this segment. And we've covered finding the slope between 2 points, handled special cases like zero and undefined slopes, and looked at real-world examples. Ruby, Myla, Justin, you've all been fantastic as always. Any advices for our listeners?
Okay, so keep practicing and soon calculating slope will feel like second nature.
And don't forget, slopes are everywhere around us. Start looking for them in your daily life.
And remember, whether positive, negative, zero, or undefined, understanding slopes gives you a new way to see the world.
Alright, thanks for tuning in everyone. Join us next segment. We'll be right back.
Bye.
16 square. 16 plus 6 that is equal to 22. 6 square or 6 times 6 that is equal to 36. And then we add. It is 6. 3 plus 2 is 5. And then bring down 2. The answer is 256. Next, 19 square. 19 plus 9 that is equal to 28. And then 9 square that is equal to 81. Then we add. That is 1. 8 plus 8 that is 16. And then 2 plus 1 that is 3. The answer is 361. How about 17 square? Comment down your answer.
Hello, math enthusiasts! Welcome back to another segment of Mathematical Podcast, the podcast where we break down complex math topics and make them super simple. I'm your host, Vanessa, and today we're diving into an essential topic for anyone studying algebra, converting the standard form of a linear equation ax plus by equals c to the slope-intercept form y equals mx plus b and vice versa. With me as always are my amazing co-hosts, Miss Ruby, Miss Myla, and Justin. Say hi guys!
Hi! So, hi everyone! I'm excited again in today's topic.
Hey, can't wait to work through some equations with you all.
Hi listeners! Let's get this math party started!
Alright, before we dive into today's topic, let's quickly recap what we discussed last time, which is really going to help us today. Justin, can you remind our listeners what we covered?
Of course! So in the last segment, we'll learn how to find the slope of a line when you're given 2 points. We use the formula for slope, which is m is equals to y sub 2 minus y sub 1 over x sub 2 minus x sub 1 and explore different types of slopes: positive, negative, zero, and undefined. The slope is essential because it helps us understand the direction of the line.
Exactly. And knowing how to find the slope is key to what we'll talk about today. Converting between the standard form of a linear equation ax plus by equals c and the slope-intercept form y equals mx plus b. So if you understand slope, you're already halfway there. Let's get into it, shall we? Let's start by explaining why we have these two forms in the first place. Ruby, why do we sometimes use ax plus by equals c and other times y equals mx plus b?
Okay, that's a great question actually. So the two forms of a linear equation each have their own uses. The standard form ax plus by equals c is helpful when solving systems of equation or when working with integer coefficients, which make it easier for certain types of calculations. So meanwhile, the slope-intercept form y equals mx plus b is perfect for graphing a line because it gives you the slope m and the y-intercept b directly. So depending on the situation, you might prefer one over from another.
Exactly. Now, Milo, what does the slope-intercept form y equals mx plus b tell us visually about the line?
So in slope-intercept form y equals mx plus b, m represents the slope of the line or how steep it is, and b represents the y-intercept, which is the point where the line crosses the y-axis. So this form gives us a clear visual understanding of how the line behaves just by looking at the equation.
Alright, so today we'll learn how to move between these two forms. Let's start by converting from the standard form ax plus by equals c to the slope-intercept form y equals mx plus b. Ready, Justin?
Absolutely. So let's take an example and walk through the steps. Consider the equation 3x plus 4 is equals to 12. So our goal is to rewrite this in slope-intercept form. First, we need to get y by itself on the side of the equation. So we'll subtract 3x from both sides. So it will be 4y equals negative 3x plus 12. Second, to isolate y, we'll divide everything by 4. So it will be y is equals to negative 3 over 4x plus 3. So the slope-intercept form is y is equals to negative 3 over 4x plus 3. Now we know the slope is negative 3 over 4. And the y-intercept rather is 3.
Oh, that's great! Thanks, Justin! Ruby, can you take us through another example?
Okay, sure. So let's convert the equation 2x minus 5y equals 15 to slope-intercept form. First, we need to move the x term to the other side by subtracting 2x from both sides. So it will be negative 5y equals negative 2x plus 15. And next, we're going to divide everything by negative 5 to isolate y. So y equals to 2 over 5x minus 3. So the slope-intercept form is y equals to 2 over 5x minus 3. In this case, the slope is 2/5 and the y-intercept is negative 3.
Fantastic! You both make it sound so easy. Let's break it down for our listeners. When converting to slope-intercept form, we're really just isolating y and making the equation easier to graph. But what about going the other way? Let's flip the script and convert from slope-intercept to standard form. Myla, want to take this one?
Sure! So let's say we have an equation in slope-intercept form y is equals to 3 over 2x minus 4. And we want to convert it to standard form. So the first step is to eliminate the fraction by multiplying every term by 2. So since the denominator of the slope is 2, so we have 2y equals 3x minus 8. Now, move the x term to the left side by subtracting 3x from both sides. So we will have negative 3x plus 2y equals negative 8. That's our standard form. Negative 3x plus 2y equals negative 8. So if you prefer you can multiply everything by -1 to get 3x minus 2y equals 8, which is a more convenient way to write it.
Nicely done! So, we've gone from slope-intercept form back to standard form. Justin, want to walk through one more example?
Sure, let's take the slope-intercept equation y equals -4 over 3x plus 5 and convert it to standard form. First, multiply everything by 3 to get rid of the fraction. So it will be 3y equals -4x plus 15. Second, move the x term to the left side by adding 4x to both sides. So it will become 4x plus 3y is equals to 15. That's the standard form. So it will become 4x plus 3y is equals to 15.
Great job, Justin! So, there you have it, listeners. Converting between these two forms is just about moving the variables and coefficients around until you get the equation into the form that suits your needs. Okay, so now, we've seen how to convert between these forms. Let's talk about why it's important. Ruby, why might someone prefer slope-intercept form in certain equations?
Okay, so slope-intercept form is super helpful when you want to quickly graph a line. You can see the slope and y-intercept right away, so you know how the line behaves without doing much work. So it's great for visualizing relationship between variables.
Exactly! And Myla, what about standard form? When might that be more useful?
So standard form is really handy when solving systems of equations or when dealing with integer solutions. So it makes it easier to see the relationship between the x and y terms when both are on the same side of the equation. Plus, when both sides of the equations are integers, it's often easier to work with, especially in word problems or real-life scenarios.
Alright, listeners, now it's your turn. We're going to give you a couple of practice problems. Grab a pen and paper and see if you can convert these equations between forms. First, convert the standard form equation 6x plus 2y equals 10 to the slope-intercept form. Second, convert the slope-intercept form equation y equals -1/3 x plus 7 to standard form. Okay, comment down your answers if you're done and we'll check your answers after a short break.
16 square. 16 plus 6 that is equal to 22. 6 square or 6 times 6 that is equal to 36. And then we add. It is 6. 3 plus 2 is 5. And then bring down 2. The answer is 256. Next.
Welcome back! Let's see how you did on the practice problems. So for the first problem, if you convert 6x plus 2y equals 10 to the slope-intercept form, you should get... What did you get, listeners? Okay, very good. Y equals -3x plus 5. For the second problem, converting y equals -1/3 x plus 7 to standard form gives you what? Very good. X plus 3y equals 21. So that's all the time we have for today's segment of Mathematical Podcast. I hope you find this discussion on converting between ax plus by equals c and y equals mx plus b helpful. A big thanks to Ruby, Myla, and Justin for breaking it all down for us. Be sure to stay tuned for our next segment when we continue our journey to linear equations. Bye! another segment of Mathematical Podcast, your go-to podcast for making math fun and approachable. I'm your host, Vanessa, and today we're continuing our exciting journey into the world of linear equations. Last time, we explored converting between standard and slope-intercept form. But at this point, we're going a step further, finding the equation of a line given the slope and a point. Joining me as always are my wonderful co-hosts, Ruby, Myla, and Justin. Say hi, team!
Hey everyone, it's me again. We've got a lot of fun coming your way for this segment.
Hello! Get your pens and papers ready because we're about to dive into some awesome examples.
Hi listeners! Ready to make linear equations even easier to understand? Let's do this!
Before we get into the new material, let's quickly recap what we discussed last time. Justin, do you want to remind everyone where we left off?
Sure thing! So in the last episode, we worked on converting between standard form ax plus by equals c. So and slope-intercept form y equals mx plus b. So we explored how to move between these forms and so how both can be useful depending on what information we have. So if you remember, we also practiced a few problems like converting equations between these 2 points or 2 forms rather to help us get comfortable with the process.
Exactly. Today's topic builds directly on that. We're going to show you how to find the equation of a line when you're given a slope and a single point on the line. Ruby, why is this topic important?
Okay, so it's important because many real-world situations can be modeled using linear equations, whether it's figuring out rents, like the rate of change in a business, or describing a relationship between two variables. So knowing how to build a line equation from just a slope and a point gives you the power to create a predictable model.
Absolutely, Ruby. And once you have that equation, you can make all kinds of predictions or understand relationships better. So it's a key skill in algebra and beyond.
Alright, now let's get into the heart of today's discussion, the point-slope formula. Myla, can you explain what the point-slope formula is and why it's so useful?
Of course. So the point-slope formula is a mathematical tool we use to find the equation of a line when we know the slope of a line and a point through which the line passes. So the formula is written as y minus y sub 1 equals m times x minus x sub 1. So where m is the slope and x sub 1, y sub 1 is a point on the line. So this formula is great because it directly incorporates both the slope and the point, making it super easy to write the equation of the line.
Thanks, Myla. This formula is powerful because it allows us to build the line equation using just 2 simple pieces of information. Justin, want to walk us through an example?
Sure. So let's work through an example together. Say we're given a slope of m equals 3 and the point on the line is 2 and 5. Using the point-slope formula, we start by plugging the given values into the formula. It would look like this. Y minus 5 is equals to 3 multiplied to the quantity of x minus 2. So first, distribute the 3 on the right-hand side. So it will become y minus 5 is equals to 3x minus 6. Second, we add 5 to both sides to isolate y. So it will become y equals 3x minus 1. So the equation of the line will be y is equals to 3x minus 1, which is now in slope-intercept form.
Perfect! So in just 2 steps, we went from having a slope and a point to a full equation. Great breakdown, Justin! Ruby, want to take on another example?
Okay, sure. So let's try an example with a negative slope to see how that works. So suppose we're giving the slope m equals negative 2/3 and a point 4 and negative 1. Using the point slope formula again. So y plus 1 equals negative 2/3 multiplied to the quantity of x minus 4. Now we're going to distribute the negative 2/3. So it will become y plus 1 equals negative 2/3 x plus 8 over 3. Now we're going to subtract 1 from both sides to isolate y. But remember, subtracting 1 is the same as subtracting 3 over 3. So the right side becomes y equals negative 2/3 x plus 8 over 3 minus 3 over 3. So it simplified the constant. Now it will become y equals negative 2/3 x plus 5 over 3. So the equation of the line is y equals negative 2/3 x plus 5 over 3.
Great work, Ruby! It's important to keep track of those fractions, but the process is exactly the same. Myla, what happens if the point we're given is this y-intercept?
Great question, Vanessa. When the point we're given is the y-intercept, the formula becomes even simpler. So the y-intercept is where the line crosses the y-axis, meaning the x value is 0. So if we're given a slope of m equals 5 and the point is 0, 7, we can go straight to writing the equation in slope-intercept form, which is y equals 5x plus 7. So no need to go through the point-slope formula since we already know the y-intercept.
That's such a great shortcut when we know the y-intercept. Thanks, Myla! Now let's take a quick break before we get into some real-world examples.
Imagine a time in the Philippines when math was not yet invented. People relied on instinct and trial and error to build their homes, gather food, and solve everyday problems. There were no numbers, no calculations, just guesswork and hope. But look at us now. Math has become a powerful tool that makes life easier, more exciting, and, believe it or not, fun. Math isn't just about boring equations or tricky formulas. It's about solving puzzles, exploring patterns, and unlocking the mysteries of the world around us. From counting your allowance to designing video games, math is everywhere. Thanks to math, we can send rockets into space, build bridges, and create amazing technology. Math is behind all of this and more. And the best part? Math helps you build confidence. Every time you solve a problem, you're growing your brain, sharpening your skills, and preparing for an exciting future. So whether you're playing with numbers, exploring shapes, or cracking puzzles, math is more than just fun. It's the key to understanding the world around us. Everyone can enjoy math. Join us and let's make math fun together.
Welcome back, listeners! Now that we've gone through the point-slope formula and worked through a few examples, let's talk about why this is useful in the real world. Justin, can you give us an example where finding the equation of a line is helpful?
Sure. So imagine you're tracking your savings over time. Let's say you had $500 saved after 1 month and $700 after 3 months. So if you want to find an equation that models your saving growth, first we find the slope using the 2 points which are 1 and 500 and 3, 700. So m is equals to 700 minus 500 over 3 minus 1 is equals to 200 is over 2 and is equals to 100. Now that we have the slope, we can use either point. So let's use 1 and 500 using the point-slope formula. So y minus 500 is equals to 100 times the quantity of x minus 1. So y equals 100x plus 400. So your savings equation is y equals 100x plus 400. Meaning your saving is $100 per month.
That's such a helpful application. Ruby, do you have another real-world example?
Sure. Now, let's say you're designing a ramp for wheelchair accessibility. You're told that the slope must be 1 over 12, and you know that the base of the ramp starts at a height of 0 feet. The point you're given is 0 and 0, and the slope is 1 over 12. So using the point slope formula, we're given y equals 1 over 12x. This equation will tell you the height of the ramp at any given distance, which is essential for ensuring it meets safety standards.
Those are fantastic real-world applications, Ruby and Justin. Now, let's move on to some practice problems for our listeners. Okay, listeners, it's your turn to practice. Grab your notebooks and pens. We're going to give you a couple of problems to work on. We'll check your answers after the break. First, find the equation of the line with a slope of 4 that passes through the point 1, 3. Find the equation of the line with a slope of negative 1/2 that passes through the point 4 and 2. Again, comment your answers below and we'll check it after the break.
So take your time and work through them carefully. We'll review the solutions in just a few minutes.
16 square. 16 plus 6 that is equal to 22. 6 square or 6 times 6 that is equal to 36. And then we add. It is 6. 3 plus 2 is 5. And then bring down 2. The answer is 256. Next, 19 square. 19 plus 9 that is equal to 28. And then 9 square that is equal to 81. Then we add. That is 1. 8 plus 8 that is 16. And then 2 plus 1 that is 3. The answer is 361. How about 17 square? Comment down your answer.
Welcome back! Hope you had fun working in those practice problems. Let's go over the solutions now. Ruby, can you walk us through the first one?
Of course, for the first problem, we have a slope of 4 and a point 1 and 3. So using the point slope formula, we're given y minus 3 equals 4 multiplied by the quantity of x minus 1. So after multiplying, it will become y minus 3 equals 4x minus 4. Now to isolate y, we're going to add 3 to the both sides. And it will become y equals 4x minus 1. So the equation of the line is y equals 4x minus 1.
Nice work, Miss Ruby. And Myla, can you explain the second one?
Sure. So for the second problem, we have a slope of negative 1/2 and a point 42. So using the point slope formula, we have y minus 2 equals negative 1/2 times x minus 4. Substitute 1/2, we have y minus 2 equals negative 1/2 x plus 2. Then we will add negative 2 both sides to isolate y. We will get y equals negative 1/2 x plus 4. So the equation of the line is y equals negative 1/2 x plus 4.
Great job, everyone! And great work to our listeners who followed along. That's it for today's segment on finding the equation of a line given a slope and a point. So before we go, any final tips, Justin?
Sure, so just remember that the point slope formula is your friend. It's a flexible tool that can help you quickly find the equation of a line in almost any situation.
Thank you, Justin, and thank you to Miss Ruby and Myla, and for all our listeners for joining us today. Stay tuned for the next segment. We will be back. today's segment of Mathematical Podcast, your favorite podcast where we break down again math topics into fun and easy to understand lessons. I'm your host, Vanessa, and today we're tackling a crucial skill, solving problems involving linear equations into variables. This is the logical continuation from our last episode, where we discussed finding the equation of a line given a slope and point. And as always, I've got my amazing co-hosts here, Miss Ruby, Myla, and Justin.
Hey everyone, it's me again and again and again. I'm ready and I'm sure that you're ready to solve some real-world problems with linear equation.
Hello! We've got some great examples coming your way. So, grab your notebooks.
Hi listeners! We'll walk you through each problem step by step to make sure you can solve these equations with confidence. Last time, we explored finding the equation of a line given a slope and a point. We used the point-slope formula to write the equations in slope-intercept form. And we learned how to handle both positive and negative slopes, as well as real-world applications like predicting savings and designing ramps.
Perfect! Building on that foundation, today we're taking it further by solving real-life problems that involve linear equations into variables. Ruby, could you remind everyone what a linear equation into variables looks like?
Sure thing. So a linear equation into variables typically looks like this. Ax plus by equals c, where a and b and c are constant and x and y are the variables. And our goal is to find the values of x and y that make the equation true. Sometimes we'll also deal with the equation in slope-intercept form, y equals mx plus b, which make it easy to interpret the slope and y-intercept.
Great! Now that we're all on the same page, let's jump into our first example. Alright, let's start with a classic word problem. Ready, team? Here's the problem. A cell phone plan charges a flat fee of $20 per month, plus an additional $10 per text message. If your total monthly bill is $35, how many text messages did you send? Okay, Myla, want to walk us through the solution?
Sure. So first, we'll identify the variables. So let x represent the number of text messages sent. The flat fee is constant at $20. So that's our starting point. The cost of text messages is $0.10 per message. So the total cost for the messages is 0.10x. The total monthly bill is $35, so we can set up the equation like this. 20 plus 0.10x equals 35. Now, let's solve it step by step. First, subtract 20 from both sides. So we will get 0.10x equals 15. Second, divide both sides by 0.10. We will get x equals 15 over 0.10 equals 150. So, you have sent 150 text messages.
Nice work, Myla. I love how you broke that down so clearly. So for anyone out there on a phone plan like this, you now know how to figure out your text message count based on your bill.
Exactly, and this type of problem is common in budgeting and planning. Linear equations in two variables then show up in situations where you have a fixed cost plus a variable cost.
Now, let's try something a bit more advanced. This time, we're going to solve a system of linear equations. Here's the problem. You're running a bake sale. You sell cookies for $2 each and brownies for $3 each. On a particular day, you sold 20 items and made $50. How many cookies and brownies did you sell? Ruby, take it away.
Okay, so this is a perfect example of how linear equations can help us solve real-world problems. Now, this is how we equate. Let x represent the numbers of Coca-Cola and y represent the number of round souls. So now we're given to a question. The total number of items sold is 20. So x plus y is equals to 20. So the total amount of money made is $50. So 2x plus 3y is 50. Now we have a system of equation. We can solve this using substitution or elimination. Now let's use substitution. From the first equation, solve for x. X is equals to 20 minus 1. Now substitute this expression for x into the second equation. Now we're given 2 multiplied to the quantity of 20 minus y plus 3y equals 15. Now after multiplying, it will become y equals 50 minus 40 because negative 2y plus 3y equals to y. Okay. Now y is equals to 10. So you solve 10 brownies. Now substitute y equals 10 back into the first equation to find x. So x plus 10 equals 20. So the value of x is now 10. So you solve 10 cookies and 10 brownies.
Great job, Miss Ruby! And for our listeners, this is how systems of equations can help you figure out multiple unknowns at once. Let's talk about how this skill is useful in everyday life. Justin, can you give us an example of how solving linear equations is helpful for budgeting?
Of course. So imagine you're planning a party and need to figure out your budget. Let's say you have $300 to spend. And you know you want to rent a venue for $200. But you also want to buy some snacks and drinks. If each snack costs $5 and each drink costs $3, you can use a linear equation to figure out how many snacks and drinks you can buy with the remaining $100. So let's set up the equation where x is the number of snacks and y is the number of drinks. So the total cost equation will be 5x plus 3y is equals to 100. Now, depending on what's more important to you, snacks or drinks, you can play around with different values for x and y until you find a combination that fits your budget.
That's such a practical example. Linear equations really help you make the sense of your financial decisions and plan better. So let's mix things up a bit with a geometry-related problem. Here it is. A line passes through the point 2, 3 and has a slope of 4. Find the equation of the line and determine where it intersects the y-axis. Myla, want to take this one?
Sure. Since we're given a point and a slope, we can use the point-slope formula to write the equation of the line. So the point-slope formula is y minus y sub 1 equals m times x minus x sub 1, where m is the slope and x sub 1, y sub 1 is the point on the line. So we have the first step, substitute the given values into the formula. Y minus 3 equals 4 times x minus 2. Substitute 4, so we will have y minus 3 equals 4x minus 8. And then we will add 3 both sides to isolate y. We will get y equals 4x minus 5. So the equation of the line is y equals 4x minus 5. So the second step, to find where the line intersects the y-axis, we set x equals to 0. So we will have y equals 4 times 0 minus 5 equals to negative 5. So the line intersects the y-axis at 0, negative 5.
Nice work, Myla! Geometry problems like this one often involve linear equations, so it's great to know how to handle them. Great insights, everyone! Thank you for all those problems. Now, let's take a moment to answer some questions from our listeners. We received several comments below. Ruby, what's our first question?
Okay, our first question from Alex. Can you explain how to graph linear equations equations after solving them?
Alright, great question. So to graph a linear equation, start by writing it in slope-intercept form, which is y equals mx plus b. The slope m tells you how steep the line is and the direction, while b is the y-intercept, where the line crosses the y-axis. Plot the y-intercept first, then use the slope to find another point. Connect those points to draw the line. Myla, do you have anything to add?
Oh yes, it's also important to remember that you can always find at least 2 points to define your line. If you have the standard form ax plus by equals c, you can find intercepts by setting x or y to 0 and solving for the other variable. So that gives you 2 points to plot.
And we have another question from Sarah. How do we know when to use substitution versus elimination for solving systems of equations?
That's a great question. Well, use substitution when one equation is already solved for one variable or easily rearranged. It simplifies the process. Use elimination when the equations are set up nicely and you can add or subtract them to eliminate a variable directly. It's really about what seems easier for the problem at hand.
Thank you, team, for those insightful answers. As we wrap up today's episode, I want to highlight the importance of practice in mastering linear equations. Remember, the more problems you tackle, the more comfortable you become.
And don't forget to explore different contexts where you can apply these skills. Whether it's budgeting, planning events, or even understanding data trends, linear equations are everywhere.
Absolutely! Plus, if you ever feel stuck, don't hesitate to reach out for help or revisit our previous episodes for more tips and explanations.
And remember, math is not just about numbers. It's about problem solving and critical thinking. Keep practicing and stay curious.
Thank you all for joining us on this episode of Mathematical Podcast. We hope you found it engaging and informative. A big shout out to Ruby, Myla, and Justin for their fantastic contributions. Tune in next time for more math magic. Until then, keep solving and we'll see you next time. Bye!